right, folks. Welcome back. Hopefully your weekend was a good one, and you're feeling recharged a little bit, ready to run here for the next week or so. All right. Today what we're going to do is we're going to talk about what's called the thin lens. Oops, I messed this up, didn't I? Yep, this one up here is the day is right, but I forgot to. That's supposed to be Monday. I know what you're thinking. I'm getting better at this online stuff, aren't I? Right? Being able to draw and do stuff like that on the notes and stuff. I know. Thank you for that. I appreciate that. um, if you get a chance, check out OK Go. The Writings on the Wall. It's a very interesting music video. I know that those don't necessarily exist on TV anymore like they did when I was a kid growing up, but it is very interesting, and I think you'll find it to be crazy how they put the whole thing together. Okay, so here we go. Thin lens. All right. So when we talk thin lens, here's the equation for it. So pause the video, write this on a sheet of paper so that you have it. 1 over p plus 1 over q equals 1 over f. All right. So when we look at this, p is our object distance, meaning that's how far away the object, the light source, or whatever we're using. Tomorrow it'll be a candle in lab. This could be the laser, if we wanted to talk about a laser shooting through there or having a different way like that. It could be a light bulb, it could be us, it could be something that's reflecting off of us or something like that, okay? And that the object distance is typically either to the lens or, yeah, it's typically to the lens, okay? The image distance, this is how far away the image has to form, okay? So what that means is that that's going to be the distance between the lens and the actual image, and that'll tell us, I suppose you could look at it and say that that could be something of importance in that if we can get that image to focus on the back of our retina, say we have glasses, we know kind of how far away we want to be, then that can be a rudimentary way of figuring out that kind of focal length for us or what we need. So, right, focal length, just where the lens has its kind of focal point. Remember that that can be in multiples, right? You can have 2f, you can have 3f, you can have 4f, you can have 5f. So you can have this repeating kind of focal length. So for us, in that combination of that object and image, it really is going to be where that focal length is going to be. Okay, let's take a look at what the setup will be for tomorrow. Tomorrow I'll have a candle lit, I'll have a lens, and then I'll have a sheet of paper that will actually cause the image to go upside down. So it's kind of trippy. And then what we'll do tomorrow is we'll figure out, how far away is the object, how far away is the image, and where's the focal length of that thing. Okay? Not a terrible lab. It is in person kind of weird because you actually get to see that candle light upside down and kind of focused. Okay? All right, let's try it out. All right, so here's what you're going to do. If you place a pencil 24 centimeters in front of the convex lens and an image forms 12 centimeters away from the lens, what is the lens's focal length? All right, pause it, see if you can run this thing. I'll wait for you to come back. All right, so go ahead and do that right now. All right, welcome back, hopefully. The nice thing about this equation is we can use any distances we want. For me, I'm just going to use centimeters because when we're in the lab tomorrow, you'll just see it as centimeters on there as well. Okay. So here we go. All right. So we got 1 over 24 plus 1 over 12 equals 1 over f. Now the object is the 24 centimeters. The image you can see there forms at 12 centimeters. Again, read contextual clues out of the problem and try and pull those. So the pencil is 24 centimeters in front. That means that that's the object, all right? An image forms. Image forms, that's going to be the Q portion of this. and then it's asking for the focal length. Now, there are ways you can do this problem by getting common denominators. I'm not going to do that at all. All right. Instead, what I'm going to do, well, I guess I am going to do that. Now, to be fair, if the numbers are clean, go ahead. I don't really want to do that. In fact, I'll do 1/24 plus 1/12, and what I'll see is that that'll give me 0.125, I think it is. All right. So then I'll just take my calculator and hit the inverse, right? Or take 1 divided by 0.125, all right? That allows me to then see how I kind of run this thing, okay? As you know, I'm not a big fan of fractions, all right? I had forgotten I did it this way, even though I looked at it about 5 minutes ago. I know, real good, right? Okay, second one, just try this one out. This one has a little bit different numbers, so we'll be able to show kind of how to do it without lowest common multiple or whatever denominator thing it's called, all right? So you place a candle at 25 centimeters from a lens that has a focal length or a focal point of 18 centimeters. How far away from the lens will the image form? Notice, it's asking for how far away the image will form. That's going to be my image distance, Q. If I place that candle at 25 centimeters, that's my object distance. If it has a focal point of 18 centimeters, that's my focal length. All right, so when I set this up, I'm looking for the image distance. Okay, nice thing is, physics is done. Hard thing is, now it's algebra time, right? We want to isolate 1 over q. So what we have to do is we have to subtract over 1/25. So we go 1/18 minus 1/25. Now this time for sure, I don't know, lowest common denominator, blah, whatever that thing's called. Okay. So what I do is I take 1/18 plus 1/25 in my calculator. All right. Or sorry, minus 1/25 in my calculator. Nice thing is I get 0.016 equals 1 over q. Right. Options are do the reciprocal. So raise this, so go 0.016, hit the caret button right above the divide, -1. Okay? If you want it even faster than that, hit the reciprocal, which is, I think, upper left corner from, or upper left from the 7, 0.016, reciprocal, -1, and you get it. Other option, obviously, too, is just take 1 divided by 0.016. So what you should see is that this thing sits at about 64.29 centimeters away. All right, that's where our lens will have to be placed in order for this object to have a focal length of 18 centimeters. All right, and again, that can be candle, lens, image, or it could be candle, lens. Well, yeah, I suppose it could be the candle, lens, and yeah, that's the same thing. Anyway, yeah, I'm struggling this morning. Sorry, folks. All right. Here's what I'm going to do. I'm going to show you what document should look like for us. So let me jump into my other stuff here. So this is what we want to get to. This will be the thin lens practice. You'll see the problems are on the bottom, answers are on the bottom, I'm sorry. If you have questions with that stuff, let me know. Otherwise, that's kind of it for the day. Hope you have a great day. Hope you're staying safe. Hopefully you're enjoying the sun/cold weather. Okay? Hope to see you soon. All right. Take care. Bye.